So we have been talking about matter. We know the difference between pure substances and mixtures. We know the difference between homogeneous mixture and heterogeneous mixture. And hopefully you know the difference between elements and compounds. And now we're moving on to atoms and molecules. What are atoms and what are molecules? An atom, the definition is right here for you guys, is the smallest particle of an element that can exist and still has all the properties of that element. So if you have, for example, a pile of iron or a piece of iron metal, you have millions and millions and millions of iron atoms that will make up that full chunk of iron metal. The smallest piece of that iron chunk of metal is one iron atom, and it has all the properties of that same big chunk of iron. Hydrogen is an atom, fluorine, calcium, iron. These are all elements. The smallest particle is an atom. Now, molecule is when you got more than one atom. You could have 2 atoms, 3 atoms, 10 atoms, 27 atoms, whatever. But if you have more than one atom and they're bound together really tightly, that creates a molecule. So a molecule is a group of 2 or more atoms that functions as a unit, and they're very tightly held together. All right, so let's focus in on molecules and talk about the different types of molecules. All right, so let's say I've got this. This would be considered a molecule. Why is it a molecule? Because it's 2 hydrogen atoms. If it was just one hydrogen atom alone, it would be called an atom. But if there are 2 of them and they're hooked up together, it's a molecule. Is this an element or a compound? Remember, in order for it to be a compound, the 2 elements have to be different. So this would be an example of an element, and this right here is a molecule of an element. All right. This also a molecule of an element. Why an element? Because it's not 2 different elements. It's just one type of element, but you have several atoms of that element. These are examples of homoatomic molecules. The term homo, remember, from homogeneous means uniform, the same. So homoatomic molecules are molecules that are composed of the exact same type of atom. If I have this, on the other hand, that's not homoatomic. Why isn't it homoatomic? Because you have 2 different types of atoms there. So this would be called heteroatomic. Okay? So when you've got a compound, the smallest portion of that compound that can have the same properties as the whole compound would be a heteroatomic molecule. Okay? Okay, heteroatomic molecule. Depends on how many atoms are in the molecule. We actually put some other terms associated with this. So can you see that these are 3 atoms? So we would call it triatomic. Can you see that these are 2 atoms? So this would be diatomic. See that this one is 4 atoms? This would be tetraatomic. Looks weird to have 2 A's here. Maybe we just need one of the A's. Tetraatomic. So the terms you guys need to know, if you have 2 atoms, it's di. 3 atoms, it's tri. 4 atoms, it's tetra. 5 atoms, it's penta. 6 atoms, it's hexa. And then you can keep on going. But actually, once you're usually more than di, they sometimes will call this polyatomic. Means that you have more than one atom. It's polyatomic. Okay, so if you were to look at a molecule like this, for example, C6H12O6, You can tell that it's a molecule because it's got more than one atom. You can tell that it is heteroatomic because it has different types of atoms. It's not homoatomic. And if you count the number of atoms, how do you do that? Well, this is an example of a chemical formula that depicts a molecule that you probably heard of in a biology class. C6H12O6 is glucose. What does this 6 mean? It means that you have 6 carbons in one molecule of glucose. This means you have 12 hydrogens in one molecule of glucose. In this one, you have 6 oxygen in one molecule of glucose. So the total number of atoms here, you go 6 plus 12 plus 6, that's 24 total atoms. So you would just call this heteroatomic polyatomic because there's no such word. We won't sit and say specifically 24. If they ask you how many atoms are in this molecule, you would add them all up, and you have 24 total atoms. How many atoms are in this homoatomic molecule? 4. How many atoms are in this homoatomic molecule? 2. How many atoms are in this heteroatomic molecule? 3. 2 plus 1 is 3. Now, sometimes with symbols of molecules, we have parentheses. For example, you could have something like this. This is ammonium phosphate. It's something that you are going to become super familiar with. You're going to be able to look at formulas like this and give me the names. And you're going to know all of this stuff. Just give yourself a few weeks and you'll get there. First thing you need to do, though, is know all your elements. So get started right away, make index cards, use flashcards so that you can start to practice the symbol and the name of all the elements that I told you guys you need to know. Okay, now something like this is, again, you're not expected to know the name of it yet, but you will eventually. This is, like I said, ammonium phosphate. You might find it in detergent maybe sometimes. All right. How is it a molecule? Yeah, obviously. This is a compound. Smallest unit of it is a molecule. Obviously heteroatomic. How are we supposed to know how many atoms there are total? Well, you can see that you've got nitrogen, hydrogen, phosphorus, and oxygen. So let's count them up. How many nitrogens do we have? How many hydrogens do we have? How many phosphoruses do we have? And how many oxygens do you have? All right, see these parentheses here? This number here means that you multiply everything in the parentheses by 3. So this is a 1. Whenever there isn't a number right next to an element, it's assumed that it's a 1. So this is 1 nitrogen times 3. So that means you have 3 nitrogens. Okay. This is 4 hydrogens times 3. That's 12. So that's 12 hydrogens. You have 1 phosphorus. See this parentheses, this is only for this. You're not multiplying this by 3. This 4 belongs to this oxygen, not this phosphorus. So you have 1 phosphorus and you have 4 oxygens. So you add them all up. 3 and 2 is 5, plus 5 is 10. So you have 20 atoms. Okay, hopefully I did that right. 4, 5, plus 12, plus 3. Okay, 17. All right, good, 20 atoms. So this is a heteroatomic polyatomic molecule. Okay, good. So you know these terms now. When you look at a formula, you need to be able to tell me how many total atoms there are. You need to also be able to tell me how many different elements there are. Okay, for this one, you can see that there are 4 different elements and there are 20 total atoms. One other little thing, and then we'll be all set with the first chapter here. Let's say I have something like this. And I tell you that the total number of atoms is equal to 12. So I tell you, okay, and I tell you what is X? What is this unknown? Okay, this is just like basic algebra, guys. Don't get all freaked up. We're not doing any calculus or anything crazy in this chapter. Just really, really basic math. So you need to figure out this and this have to equal 12. So we have these two are going to be exactly the same. So 2x is equal to 12. So what would x be? X is equal to 12 divided by 2, which is equal to 6. So the formula would be C6H6. This happens to be the formula of the molecule benzene. If you're going to be taking Intro to Organic, you're going to be dealing with benzene and all sorts of fun stuff. But I just wanted to give you an example of something like this because sometimes you will see on quizzes and homework and stuff where they tell you what is X. Let me try to find another one. This is another typical one that they love to do. The glucose one. You have X, 2X, and then X. And then they tell you all of this is equal to 24. So what you need to do is figure out, all right, what is X? So this is 2X and X and X. So this is 4X. 4x is equal to 24. X is equal to 24 divided by 4, which is equal to 6. So if x is 6, so then this would be 6, and then 2 times 6 is 12, and then this would be 6. So it would be C6H12O6. Okay, so I just wanted to give you an example like that, and we are all set. I hope I covered everything. I think one of the things I may have forgotten is that the main elements in the human body, carbon, hydrogen, because basically your human body is made up of proteins and carbohydrates and lipids and nucleic acids, DNA and RNA. So you got a carbon, hydrogen, nitrogen, oxygen. Those are the main elements there. I told you guys about the universe and the Earth's crust. So I think we are all set. Don't forget to read the chapter. Please don't just depend on these videos. Read the chapter. Look at the what you need to know list, watch the videos, you'll be all set. Okay, we will start the next videos a little later on.